Our next speaker is Dave Baker from Element, staff engineer working on all the voice over IP implementation at Element, and MatrixRTC, which is the real-time component of Matrix, which is the chat protocol we've been using all week. So, well, thank you, and take it away.
Thank you very much. Welcome. Thank you for having me. Right, so I don't know how many of you have already seen Matthew's presentation on Third Room. Hands up. Okay, a few, not many. How many people have heard of Matrix before? Okay, excellent. Right, okay, so you might find the first part of my presentation a little bit dull.
You're talking about the movie, right?
Yeah, the movie, yeah. So I won't spend too much time on that, but I'll give a brief. I've had a few questions over the course of the conference over what's Matrix and Elements and that kind of thing. So I'll zip over it a bit, but we won't dwell. So yeah, I'm going to give a quick introduction to Matrix, what MatrixRTC is, what Element Call is, and how that relates to MatrixRTC, and then what we're doing next and what our plans are. So yes, you might recognize this slide from Matthew's briefly. Matrix is mostly sort of chat, but is also a generic fabric for lots of things, including interoperable VoIP and open comms for AR and VR, and anything that involves live data, anything that you can think that might, where you get a JSON blob from one side to the other side in reasonably real time, or in the case of MatrixRTC, actually real time. That's what it's all about. So I said I'd spend a bit of time on Matrix versus Element and what the two are. This is that section. So Element is the company that employs me and is the commercial organization. We sort of work like a regular business. And sell to governments and do hosted Matrix services. We host home servers, Synapse home servers for people. So you can come to us and we'll host a home service for you and you'll make it nice and easy. You can go through on the website and click Element hosted services and get your own home server up running in minutes. So you don't have to worry about hosting your own home server if you don't want to, but you can because it's Matrix and it's all open source. So that is what Element basically does, and that's how Element works as a company. Matrix is a foundation. It's now registered as a charity. As of about, I think, 3 o'clock yesterday, you could sign up to Matrix, to membership of the Matrix Foundation, if you want to support us and support what we do. How I am related to the Matrix Foundation is I'm on the Matrix spec core team, and the spec core team drives the actual Matrix specification. Whenever a new thing goes into the Matrix spec, basically there's a bunch of us that look at the proposal on GitHub and say, is this a useful thing? Is it working the way that we would expect it to work? Is it open, and will it allow everybody to participate in this standard in the way that they would expect to be able to participate in it? And we all tick our boxes, and if we're all happy with it, it goes into Matrix. So yeah, I obviously keep an eye mostly on the video and voice and telephony side of things that go into the spec. Most recently, we've merged a bunch of the next generation one-to-one video calling, which is a bit of an iterative improvement over the old video calling, and that's finally now actually gone into the spec. So yeah, that's how Matrix and Element works. That's the open specification. Lives on spec.matrix.org. You can go and see it. It's all there. Client-server API, server-to-server API. You can't read that. And then the little ones that you probably might have less reason to have interacted with, like the application service API and identity service API and push gateway API, which I used to look after in a previous life. That's all open. That gets released more often nowadays, because we're better at actually updating it. Matrix is an ecosystem of lots of things. These are all the, well, actually, this is not all of clients by any stretch of the imagination. These two up here are the commercial ones developed by Element, the company. That's Element Web and on desktop, which you've probably all used because you're all on the ComCon space and chatting, I hope. Yes? Yes. And then mobile, which you might also have downloaded. You can get to the same rooms as you would expect through the mobile client. We maintain that as well. But you don't have to use Element. It's all Matrix. You can use any client you want. You can use WeChat if the command line protocol is your thing, or if you want a Qt client, you can use Quaternion or an Echo or Fractal. That is the first page of matrix.org/clients. There are more. Too many for me to put on one slide. Servers. There's mostly the most popular client is Synapse, one written in Python, and again written by people employed by Element. The code goes towards the Matrix Foundation to keep everything open. But that's just that one down there. There's other ones. There's Conduit, excellent. It's written in Rust. It's really coming along. It doesn't have all the features of Synapse, but it's fast, works very well. Dendrite is also maintained by us. Is more leaning towards peer-to-peer matrix, but we just experiment with things written in Go. Yeah, there's lots of servers up and coming. All that stuff. There's bots, bridges, things to integrate with other things. You can, yeah, Matthew mentioned this as well. You can bridge from Matrix to WeChat to GitHub to email to SMS. If there's something out there that you can think could be bridged to a chat protocol, somebody's written a bridge or a bot for it. This, again, you might recognize that I'll go over very briefly. I'm sure you're roughly familiar with the architecture, but in case you're not, it's not all one home server and connecting into one home server. So you have these home servers, for example, and then these clients around the outside. So I can be on, say, that's me on matrix.org and the matrix.org home server, and then there could be someone else on the element.io home server, and we can all be in the same room. It's completely decentralized. There's no one single point of control. The rooms are replicated between each other, so the room data doesn't live just on one home server. You join a home server, or you join a room, and then your home server joins a room by talking to the other home servers that know about that room, and then all the data for that room is distributed amongst all that servers. It goes, copies all the information, not necessarily all at once, but it does it in the background. When I send a message from here, it goes to here and then stores and forwards to the other home servers in a full mesh. So store and forward semantics. And it's all E2E as well. Well, that's not all E2E. In an E2E room, it is all E2E. You can use E2E if you want. If you're in a public room and you don't want E2E, then don't use it. The advantages of having E2E in a public room are kind of questionable. So it's up to you whether you use it or not. But yes, everything supports E2E, in which case all the messages in your room will be end-to-end encrypted, and these clients will go and distribute keys among themselves, and it will work. So yes, basically the concepts that you have to understand Matrix, the main thing is these rooms. It is fundamentally sort of designed around being a chat protocol, and so we have these rooms, but it's a useful organizing concept when you're using it for other things as well. So you can imagine, say, if you have your home and all your devices in your home, like you might model your entire home as a matrix room, and you would have your fridge and your thermostats and your car, they would all join the same matrix room, and then they just all post JSON into that room, and they'd be able to talk to one another. So it's a kind of useful organizing concept. They stay relevant, and so that's why we have the two different types of event. Those will become relevant when we start talking about MatrixRTC. The difference is that state events have a state key. So when you replace an event with the same state key, this is where it gets a bit technical. The old state event will go away, so you're directly updating the state of the room. there's JSON in this presentation. This is how it actually works. This is what it looks like. This is a room message. This is me saying hello. And yeah, I mean, that's it, really. There's a lot of stuff in there, like this transaction ID, which helps you to make sure you're not sending the message twice. Or when you do resend it, you don't get two messages, things like that. There's an event ID, which uniquely identifies this message. Timestamp, fairly obvious, that's me. But yeah, basically the meat of it is here. It's a text message. The body says hello. That's what a message looks like. So now on state events, this is somebody called Bert joining a room. Again, you've got all this stuff, the event ID, the room ID. This is the state key. In the case of a membership event, the state key is Bert's name or Bert's user ID, and only he has the right to update that. You know, the content is just saying, I'm joining this room. Call signaling, right, finally, we get onto something that's actually VoIP-related. This is our old one-to-one VoIP implementation, and this is what calling looks like in a one-to-one call. If you go to Element and go to a direct chat with somebody, hit the call button in the top right, it will send this, something like this. m.call.invite is the type. So that's the type of the event that you're sending. Randomly generated call ID, some capabilities. We can do DTMF over these things because WebRTC has DTMF in one direction. If you want to do that, some people wanted to do that. Obviously, I've chopped the SDP. I'm sure you're all very, very familiar with SDP. There's a lot more of that. It goes on for lines and lines. But yeah. We just literally just take the SDP from the browser, transport it over JSON, ends up at the other side. There's a little bit of wrapping as well. We have stream metadata as well, where we say, oh, well, the audio feed, that's muted at the moment, so the other side can see whether you're muted or not, and the purpose of this, whether it's a user media or a screen share. I'm not going to show you the rest. Obviously, it's a standard SIP-like exchange. We have m.call.invite, m.call.answer, as you might expect, and then a select answer as well to do the two-way ACK. Not going to go into too much detail, but that is basically how one-to-one caller works. So now we've got that. That basically gives us an open signaling standard for WebRTC. WebRTC being media only. If you want to set up a WebRTC call between yourself and your mum, it's great. It's an completely open standard for media, but you can't because there's nothing you can use to set up the call. You have to go to a specific provider, and some kind of dance with WebSockets will happen probably, and this SDP will be exchanged in some way between two browsers or two WebRTC stacks. WebRTC doesn't come with a open, universally accessible standard for just setting up a call. So that's kind of what this part of Matrix aims to do. It's open, it's federated, so I can be on my home server, somebody else can be on their home server, we can still call, we can still talk to each other in an open email-like world, which is great. Can we take this further to multi-party calling? That's what our aim is now. So we're back here. These are the 4 things. And those are the 3 things, really. Quite a lot of it actually involves real-time communication. So that's where MatrixRTC comes in. It is low latency, real-time, rather than using JSON and HTTP going via home servers and then replicated via all the home servers, which is very reliable and has lots of useful properties, but is less useful when you're talking about video. Can we use that to set up WebRTC connections that are really fast and go straight from client to client or go over UDP or RTP to do all this stuff? And can we layer, get all the advantages of Matrix while doing that? That's what we're talking about. So this is sort of how your a standard video conference mostly looks in a world where we have Zoom or Teams or something like that. This conference focus will be probably, almost certainly, more than one box. It will be distributed in some way, but it's all run by the same company. It will be reliable in some way, but it's all the same entity, essentially. So this is, say, Microsoft or Zoom, or there is no federation really out there now. You go to make a video call, and you all have to go to the same website, which is fine. Normally works. It's not ideal. You wouldn't have accepted it if mobile phones worked that way. Really, you wouldn't have accepted to buy an iPhone to be able to call somebody else on an iPhone. Yeah, that's kind of the way it works with messaging. It shouldn't be. It should be open, and we should all be able to talk to each other on a level playing field. MatrixRTC is, I stole this diagram from Matthew's presentation, so you might have seen it already. These are our home servers here. And then we've got this other layer of focuses, as well as our clients. So our clients are now, as well as connecting to our home servers, they also have media connections to these foci that are exchanging media between them, again in a full mesh in this case. So we've essentially got this other layer on top of the old matrix network. It can be, so they can also be a peer-to-peer. They can either go via these foci, or they can go peer-to-peer. We'll talk about that more in a moment. Clients own all the business logic. All they're really doing is exchanging media. The network is designed to sort of get in the way as little as possible. So yeah, this is for your low delay and low jitter applications. Like this. These are our kind of use cases. Standard video conference there. This is Element Call. I'll show you this a little bit more later. Bunch of people in a grid, all exchanging media. I think that one was actually full mesh. I think that was us pushing full mesh to the very limits there with that number of people. There's a slightly different use case. This is a video and audio room where it's essentially the same thing in a slightly different experience. You go in, you have a room that is dedicated as a video calling room. You hop in, other people might be in there, you have a chat. And if you haven't seen Third Room, do come and see it. It's really cool. We've been working on this as sort of sci-fi side project. So other people in the company, not my work. But yeah, you can jump into, you essentially upload a load of GLTS data into a matrix room and then all join the same virtual world and your position, and you can have voice chat as well, and that's all synced via MatrixRTC, via calling on top of Matrix, so you can see each other move around in real time. So yeah, that's all over a WebRTC data channel, so that's very low latency. And there are stuff like this, like whiteboards. Of course, when somebody's writing on a whiteboard, you want as little latency as possible so you can see them draw stick figures in real time. It's all going for all that kind of stuff. So we're getting technical again, and down into the nitty-gritty. And this is where we need to remember normal events versus state events. So how does the signaling work? It's still all matrix events. We've got this m.call event. This is a state event. You post this into a room. When you do, everybody else knows, hey, right, there's a call happening in this room. Maybe I want to join it. Maybe I'll advertise to my user. They might want to join it. We should signal in some way that a group call has started in this room. It might have, you'll see the event in a minute. We'll say roughly what the intent of the call is and how you might connect to it. When you actually want to connect to it, there's a different state event called m.call.member that says, I am joining this call. Here is information about how to connect to me. Right. There's an m.call event. just in case you get confused and see one in the wild, it's not in the spec yet, and so it has this. That's the actual type at the moment. When it goes into the spec, it will be m.call. Don't worry about it too much, just in case it's confusing. Yeah, I mean, it looks a lot like the other state events, really, and there's not much in it, actually. Most of it is just saying, I'm starting a call in this room. This is our push-to-talk extension, because we were playing about with push-to-talk calls. They work too. It was really, really cool experience. This one isn't, though. It's intended to be a call in a room. It's a video call. That's about it, really. That's all there is to it. This is the m.call.member event, or in this case, all.matrix.msc33401. There's a little bit more to this. I had to squish it a bit to fit it on the slide. All the common fields, I've left them off because they're not very, you've seen them already. Again, this has got a state key. So this is Alice's state event. Only she can post it. It shows that she is joining the room, and when she leaves, she updates that with her same state key, and then we know she's left. This is the interesting bit. These are my devices that I'm joining the call with, and these are my feeds. So this is saying that Alice is publishing one feed that is her user media. Eventually, you will know that when you're joining this call, you'll know that Alice is posting this feed, and you'll want her user media, so you'll say, Alice, can I have this media stream, please? And the client will go, yes. That's how you get the media. This stuff is how you negotiate what SFU or focus you're all connecting to. The reason we have active and preferred is to work around the situation where, say, one person joins a call from New York, starts that call on their New York focus, wonderful. Then everybody else goes. Somebody else joins in London, joins the call, and because there's only one focus in the call at the moment, they join the New York focus because there's no reason not to. That's fine. It's going across the Atlantic anyway, no problem. Then somebody else from London joins and sees that they're all currently using the New York focus. Well, I could join the London focus, but then somebody else is going to be stuck on the New York focus. So really what I want is for the other person to switch over to London. But if we just have one focus that everyone's connected to, then they go connect to New York. And eventually, if everyone else connected from London, you'd end up with all their feeds going over the Atlantic for absolutely no reason whatsoever. So we had a bit to think about this and how we could signal this and work around this, and came up with active and preferred foci. And it's a reasonably not too complex algorithm of how you decide whether you're going to connect to the active one, i.e. the one that you're using at the moment, or the one that you would prefer to use. So that second person that joined from London would say, I am using the New York focus right now. I would prefer to use the one in London. So if that person then sees that somebody else is using the London focus, they can hop over. That's what that's all for. You probably don't have to worry about it very much. The idea of MatrixRTC is you'll use a library for it, it will all go away, this is all under the hood. But that's the kind of thing that's going on under the hood. They can either be full mesh, where all the clients are talking to one another, or they can be based on these foci, or they can be hybrid. You can have a SFU, or you can not have an SFU. This is full mesh. These three clients have got they're all connected to their respective home servers. This one's connected to that one. There's the green connections, but their media connections are full mesh. So all of those media connections are connected to one another. It's obviously very simple. It doesn't really scale. We managed to get about 8 people, I think, in one full mesh call before it dies, unsurprisingly. But if you don't want to run a focus and you've only got, if you're running for one for like your family or something for a few users, it's ideal because you don't need very many people. So you don't have to run a focus if you don't want to. Or you have this more complicated diagram, where you have two servers, two of which have foci, because they've set one up, but this guy hasn't bothered. He doesn't want to set up a focus, so what does he do? Well, why can't these other clients, why can't this client connect to one of these other foci? You can. So you just connect to it. You just use somebody else's, because it's already serving media anyway. But you've only got the streams going once between these two, because they only need to go once. And it kind of just arranges itself in the most efficient way. So, how do we actually set up media connections between the nodes? Well, actually, they're just matrix one-to-one calls, as we saw earlier. It's the same thing. There's no difference in the signaling. The only difference is that instead of it going into the room, where it did before, they go straight to the device over two-device messaging. And the reason for that is, one, because we already know which device the user is joining from, so we don't need to send it to the room. And the fact that we can do that means that the IP addresses and all that stuff in the SDP doesn't need to be saved in the room so that you can see it 2 years later what IP address you were using, which is kind of non-ideal. No, you don't have to. Just go straight to the client. You don't have to worry about it. So that's why that's like that. And again, this can all be end-to-end encrypted, and call it is. You just turn end-to-end encryption on, and all these are only visible to the clients. As to how you actually identify media streams over MatrixRTC, each one of them has what we call a media UUID. So you will go and ask for a stream by its media UUID. Or maybe you don't want the stream. Maybe in something like Third Room, you might just want somebody's voice activity, so you know when they're speaking. So you know that when somebody's behind you and they're speaking, you might want to unmute their audio. Or you just want to subscribe to their mute state, so that you know when they're actually intending to speak. You can do that too, and you don't need to, well, this is all a little bit sci-fi now, but the idea will be that you can just subscribe to the metadata rather than the actual media. So yes, on the subject of sci-fi, where are we right now? This is the spec. It's divided into two parts. MSC is a matrix spec change. It's fairly self-explanatory. MSC 3401 is basic full mesh group calls and defines all those two events you saw earlier. Then there's split out into 3898, which is the stuff that adds support for focus, conference focuses and that kind of thing, mixers. So that's where the spec actually is. It's all written. It's still in MSC, which means it might change, and it may very well change quite a lot, actually. But there is the spec is out there. As for implementations, it's implemented in the element call client. So that's a standalone web app. You can go there and use it. Element call is also embedded into Element Web Desktop. I'll show you that in a second. If you've seen Hydrogen, the very lightweight client, that has a separate implementation of MSC 3401 that you can connect in. And obviously Third Room uses it for voice as well. We also have an SFU called Waterfall, which is actually originally contributed by Sean Dubois. It's based on Python, and it federates and will forward streams between other versions of itself as it speaks MSC 3401 and MSC 3898. But yeah, it is also building an SFU from scratch, which is kind of hard. So it works, we've used it, we have used it for meetings. It just has a few kinks to iron out. It's on its way. Exciting stuff. Our latest project has been embedding LiveKit into Element Call and seeing if we can do an version of Element Call powered by LiveKit. We can. It was really cool. Because LiveKit provide a very powerful open source SFU. Why would we write one when there's one already there? The only problem is that LiveKit speaks its own protocol rather than MSC 3401. It's even got end-to-end encryption coming soon. There's a PR out for that. So we've been thinking about how we can use this for MatrixRTC rather than rewriting one. So can we make a version of element call powered by LiveKit? Yes, we have. Daniel, my colleague in Germany, has been hacking on it for not that long, actually, about 4 or 5 weeks. And then last week, we all had a group hackathon on it, Hack Week. And now we have a version of element call powered by LiveKit. It just uses React's LK components, so it doesn't have this MatrixRTC style federation that I've just been showing you. It is one client connects to LiveKit. But yeah, basically the plan is to sort of take that, which works, and then slowly replace it with bits of Matrix as necessary, like maybe take my LiveKit SFU and make that speak MSC 3898, or even maybe just build a bridge so that we can have the LiveKit FSU unmodified and have that talk translate the signaling. Demo time. Right. So let's first of all see, I'm going to show you, before we talk LiveKit, this is a standard element. This is my test account. I just wanted to show you element call embedded in a standard element. So this has got all the options turned on. I'll show you where the options are if you want to turn them on themselves. Element call video rooms and new group call experience. So this is not what you get by default, but if you go to develop.element.io, you can turn this stuff on. So if I hit the video button now and do a video call, I get a choice of either Jitsi or element call. Obviously, I'm going to pick element call because that's what I'm talking about. There we go. This has got my OBS feed at the moment, but I can hopefully switch that for my FaceTime camera. Hello. Enjoying that. That dinging you heard was me getting a notification that I've started a group call in here, and I can go join it. I'm going to mute that to avoid horrible howl around. No, my luck, that one's not working for some reason. Oh, but it's got audio. There we go, it's a standard video call. That is element call embedded in element. Goodness knows why that's now black. Won't worry about that too much. Yeah, probably something like that. Usually works. But anyway, that is the old style element call. That was going full mesh, even though there were only 2 video connections. That was what that was doing. So that works today. Again, that would have been limited to about 6, 7, 8 participants in practice. But you can use it, and it's there. I won't bother showing you the SFU because basically it looks the same. But
how do you tell the browser to use the SFU? Can you show that?
It's in a config file. So it's just configured in JSON. So at the moment you will set a particular element up to run in SFU mode. So at the moment we've got a pull request, and our pull request build automatically, so it's on a branch. I'll make that bigger so you can. Right. So this is a URL to that. You can try joining this on your phones, and I hope that it will work. I will have to get about another 10 seconds to try and join this call before I try and join it myself. See, everybody's scanning. Yep, got it. Okay, good. Right, so that means I go here. Now, right, PR 1092, this is our live built PR. Actually, we put it on a better URL now, so I could use a different one.
I got a 429. Too many requests.
Oh! Well, that's interesting. Yeah, well, in this case, Netlify got DDoSed, which is a bit more concerning. Hopefully I'll be able to get in. That's looking good. Okay, yeah, there we go. Let me go and say, join now.
At least 11 other people in there.
Yeah. There we go. Oh, look at that. We've got Half Shot there from the Third Room Laptop. Hey, Half Shot. And I can see, oh, yeah, Florian. He's one who basically coordinates all the magic. Yes, we can hear you. Hello, you are live at ConCon. Please do not swear. Right, so that is, oh, yeah, this is all LiveKit. This is going straight to our LiveKit SFU, which is running in fact, I can even show you the Grafana dashboards. Hopefully there I can see, yes, there's apparently, do I need to refresh that perhaps? Make sure that's up to date. Come on, Grafana. But yes, 11 published video tracks. It's doing hardly anything, 0.15 of a core. Yeah. And it's just shot up in CPU usage. Now we've started using it. There's 3 rooms and 15 participants. So this, yeah, I mean, the beauty of LiveKit is you get all this for free. I mean, I looked away for 1 minute last week, and boom, this Grafana was set up. I barely even had to do anything. Ops went and did it themselves. LiveKit has a built-in recipe for deploying this stuff and deploying it in a cluster as well. It was magic. You're right, it should show the element called UI as well, because the other thing I can do is switch between, this is freedom mode, where I can drag a tile, so I can put myself on the left here, and I can maybe, I don't know, put Timo up there, hi Timo, and put you next to Timo too, so there's lots of you in the same place. Oh, there's Enrico as well, let's put him up there, I want to see him. And then I can put Half Shot at the end, and oh, Lucas, look, hello, Lucas is he's using LiveKit. He can go over there.
Can you turn off one particular person?
I can't turn them off if I just don't like them.
If you don't want to see one particular guy.
No, that would be an interesting feature request. I don't think they can mute themselves, but we haven't thought of that one.
Usually need that feature.
Ah, interesting. What we can do is switch to Spotlight, and at the moment that's showing me because it thinks I'm talking. If I mute myself and somebody else talks.
I can talk if you like.
Hello, Florian.
Yep, then automatically, right?
Lovely. Yes, it switches to him automatically, makes his feed big, and then I've got everybody else on a little scrolly sidebar here. Florian, do you want to try starting some load tests so we can see it with lots of participants and see if we can break it?
I think now maybe you can go back to freedom mode, which is quite impressive to
let's
present.
go back to freedom mode. There we go. Yeah, there they are. That's, you may or may not recognize the standard LiveKit test videos, but now that I've got all those, I can go to Lucas and make him. His video's just died. That's unfortunate. That was good timing. But I can make Florian big, and then you can drag him around like that. So all these videos now they've got, LiveKit does this automatically there. Now they've disappeared off the bottom of the screen. I can scroll them in, and then you can see them appearing. I think this is, the ones without videos are because they're subscribers, so they're not publishing video, because that's how the load test works.
How's your CPU usage?
How's our CPU usage at the moment?
Local or on the SFU?
Local, it's... Oh, local, there you go. It's not... I mean, this is a M1 Mac, so it's a thermonuclear reactor. So what this can do is not necessarily a good gauge. But yeah, it's not particularly struggling. Doing just fine. Yeah, there you go. There it is. And I'm going to wrap up now because I am at about time. So thank you, everybody that joined and wrote. And I'm going to say, any questions?
Thank you very much.
One thing that wasn't clear for me, for audio, are you
Oh, so you're using SFU for that, or do you have audio mixing? It seemed like your spec mentioned mixing, but everything you talked about was strictly SFU.
Yes, good question. So it's very much designed so that you can do mixing if you want. It's why we call them foci, not SFUs, because they are generic conference focuses and they're intended to be. So if you want to mix audio, then you can. In practice, we are doing, everything's SFUs, so we're just stream forwarding, but the spec is designed such that you can do it how you want.
Thank you. Oh, well, let's start from over here.
All right. I have two questions. First, you said that it's an open spec, but does a single entity actually control the spec? Just because it's open doesn't mean that it's,
yeah.
royalty-free and all that.
This is sort of where the Matrix Foundation comes in. So the foundation is a guardian, if you like, that looks after the spec. So yes, it is a single entity in a sense, but it's an entity that's run collaboratively and governed in an open way. We deliberately got governors and guardians in from people that weren't related to the company. The spec core team at the moment is slightly element heavy, but we have one person that's not employed by Element deliberately. So it's set up in a fashion that is hopefully resilient. So obviously, yeah, it's not a complete free-for-all, so everybody can just throw specs left, right, and centre, but it's designed in a way that is an open, governed organisation.
Okay. And the second question is, what's the relation to XMPP? There used to be such a protocol in the past that used to be open and more or less the same motivations, goals, and things like that. What happened?
Yeah, so we, in our past, in designing these protocols, we used XMPP for a time, and it worked reasonably well, but it doesn't have any. Well, XMPP has lots of things. They're all add-ons to the spec. Sometimes they get adopted, sometimes they don't. You have to pick and choose. As standard, it doesn't have history, which we found really annoying, and had to hack it in. And it doesn't really have rooms. It's mostly one-to-one. We are all IRC natives and really engaged with sitting in a room with other people. So we really wanted that, and with XMPP, you have that's one single entity that runs that room. I think those are the major differences. There's a lot of.
Around, right?
Oh yeah, absolutely, yeah. XMPP lives on and is all used under the hood for a lot of things, but those are the major differences.
Thank you. Well, I'll just go around the room.
Hey, I just have a quick one on the hybrid model. You mentioned that in order to use the SFU, you gotta configure it in some JSON file. So
Yes.
how do you envision the hybrid mode working, and where would your threshold be? Like, for example, in our case, we do one-to-one is peer-to-peer, and then we switch to SFU for more participants. Are you considering like doing up to 8, or what are your thoughts on that?
Yeah, it will mostly be the client's choice, really, at what point it switches and decides to use an SFU. As for trust, yeah, the client will it'll probably be shipped with the home server, so that you will ask the home server, do you have an SFU that I can use? Oh, yes, okay, I'll get this one and use that one in preference, because that's the one it comes with, so that's the one that's probably closest to you, or at least governed by the same organisation, but other people will be able to use it. So yeah, it's basically normally configured at home server level, but you could, it's just something the client has to know about, so you can inject it into the client config and the client will know about it itself. Mostly however the client wants to do it, really. We'll make some recommendations in the spec as to when you probably switch to SFUs, but it's generally designed to be as open as possible.
Thank you. Renzo.
How many peer connections are in use when you use the SFU mode? Do you use separate peer connections for sending and receiving, one to do everything? So how do you handle glaring case, this sort of thing?
I'm glad you asked, actually. So we initially used one peer connection for everything when we were doing it in Waterfall and MSC 3401. But LiveKit uses two, one in either direction, one for the upstream, one for all downstreams, which seems to work very well in practice, and you don't get problems like glare and which party is setting up the call and which direction that's happening in. So it has a lot of advantages. So honestly, we might just switch to that. So yeah, at the moment there's two different modes.
Yeah, sorry, just one very quick question as well. So is the data channel still required for the setup as you described before, or is that when you switch to LiveKit, do you, for instance, you mentioned the possibility of using a bridge to actually bridge between the Matrix API and the LiveKit API. So I was envisioning how easy it would be, for instance, to do the same for other SFUs. So in my case, for instance, I'd be interested in checking if Janus fits the bill because it uses the same separate peer connections approach in that case. But the data channel may make it harder.
Possibly, yes. I don't know how easy it would, things like that might make it more difficult to bridge, but yeah, in principle, you should just be able to bridge the SFU, the SDP through and have them connect, and have something that speaks MSC 3401 and then connects into the, obviously if that had to bridge the media, that would be much less of an advantage, get the advantage of running your SFU in the first place, but yeah, I'm not entirely sure how well it would work in practice with things like Janus, but yeah, it's...
Okay, for the last question. So a couple of questions. Around federation, have you been able to federate with some of the closed systems out there like Zoom or MS Teams or Google Meets or WebEx? And the other question is around SFUs. You seem to be investing in multiple different SFUs. You have your waterfall based of Pion, you have LiveKit, and then you also, at some point, I thought were using Jitsi, if I'm not mistaken. So a couple of things there.
Yes. So we would, basically, it's more of a linguistic difference, really. We consider things to be federating when they're sort of actually participating in the network as full matrix clients. So we'd never say that we were really federating with Teams or things like that. Although obviously they could, but that would be on Microsoft to say we're implementing the matrix federation interface, and then absolutely that would happen. That's not happened with anybody yet. Instead, what we do is bridging, where we usually involves taking either the client API or some other API that they provide, taking that out and then putting it into Matrix in a notional sense. So bridging, absolutely, yes, we very much do. Federating with those systems, will be a lovely future, and will definitely be something I would like to see, but unfortunately not yet. As for SFUs, yes, Waterfall was the one that we have been working on, and we're hoping that we would be able to build on Pion, and it will be amazing. We have switched to LiveKit mostly because it was so easy to get up and running and gets us something running like right now. So Waterfall's not dead. We'll continue to work on it. It'll continue to be a native MSC 3401 SFU. Jitsi is what we've used in the past, and we're probably slowly moving away from, and was only really embedded by embedding the Jitsi web interface into Element. So that is basically the story there.
Thank you very much.
Thank you.
And good. So now it's lunch break. I'll see you back here at 2 for a workshop on GET user media and browser media.